Alright guys, so like I said, these videos that I'm going to be posting here to Canvas are really just an opportunity for you to go back over stuff that we did in class, maybe something you didn't get the first time around, or maybe it's a way for you to review before the test. But I want to use this as an opportunity for you to make sure you understand the material. If you're absent for a day too, that's another great opportunity to use these. And just so you know, I kind of combine a couple different topics into each video, and so feel free to be clicking around and click through the video to get to the part that you need to see. And not only that, there's practice problems throughout it as well, so be checking those out, pause the video, work through them, and get some more practice with what we talk about. And so this first video, what we've been talking about is production possibilities curves and opportunity costs. And so I want to go through and talk a little bit about those. So in class we used the example where we said that you get home from the end of the day and you have 6 hours, and you can either do your homework or you can watch Netflix. And so we have a similar example here. Let's say you're baking, and you can either bake brownies or you can bake cake. Now, a few rules we want to make sure we abide by throughout this. Remember, you're making one or the other. Let's say you only have room in your stove for just in your oven for just one. We consider both to be productive uses of our time. It's just that we're doing one or the other at a time. Our resources are fixed as well. You only have one oven, you only have so many pans for baking, whatever it might be. And so what this might look like in terms of different points that we might achieve is, let's say we focus all of our attention on making cakes throughout the day. Well, then we could make 5 cakes, but if we're putting all our attention in making cakes, we wouldn't be able to make any brownies. Now on the flip side, maybe we focused all of our time on making brownies, and if that was the case, we wouldn't be able to make any cakes. Now, we could split our time up and maybe we spend some time making brownies, some time making cakes. We could do that. And we have all these different options throughout our day. So if we were to go ahead and graph what this might look like, we have cake here on our Y, brownies here on our x-axis. If we were to graph these points, and point A goes right there, B, C, D, E, F. These show our different options that we had seen in our chart above. And what we do then is we connect these dots, and once we connect these dots, we have this curve, and we call this curve our production possibilities curve. You might also see this sometimes called your production possibilities frontier. Either way, just know it means the same thing. What is the purpose of this? Well, it shows us our possible points of production. If we were to use our resources efficiently, how could we produce? What are our different options where we're being fully efficient with our resources? And that's what that line represents. Now, maybe I said to you, hey, I want to be able to produce today. I want to make 5 cakes and 2 brownies. Like at this point out here, 5 cakes and 2 batches of brownies. And what we might do is look at this and say, well, this is beyond our production possibilities frontier. This is beyond us using our resources fully efficiently. And so what we would say is that this point out here is impossible. Why is it impossible? Well, we don't have enough resources. Our resources are too scarce. Remember, we said we have a limited amount of resources, but we have unlimited wants and needs. And so because of that issue, what we see then is that we have to make decisions, and this is a decision that we're not able to achieve because of scarcity. So anything outside of this line is considered to be impossible. Now, if there's a point inside of the line, maybe during the day I produced 3 batches of brownies and 1 cake. We see this is inside of the line. I didn't quite achieve hitting my production possibilities curve, and so what we say is that I was inefficient. Anything inside of the line, we're not using the resources to the best of our ability, and therefore we're being inefficient. We're not fully using our resources. Now, a few rules I just want to make sure that we abide by as we go through and work with our production possibilities curve. One thing to always keep in mind is that our resources are fixed, both in quality and in quantity. We'll talk a little bit more about this a little bit later in the unit, but just know that our resources are fixed, quantity and quality. We only have so much land, so much labor with which we're working. Also know that anytime we're along that production possibilities curve, we're saying that our resources are being used efficiently. So we're using them to the best of our abilities along that curve. And finally, at any time, if we're using these resources, we're using them for one or the other, the production of one good or the other. So this is a time I want to stop and kind of talk about this term Tinstaffel. This is an acronym which means there's no such thing as a free lunch. When we look at this, it's this idea that you might get something for free, and you say to you that it's free, but if we keep it in mind in terms of the whole economy, it's not necessarily free, and the reason it's not is because somebody's always paying in some way. And this might not only happen with, say you win a free lunch from a restaurant, but also in terms of your life. Something might seem free to you, but oftentimes the payment for this comes by having to give something else up. And we call this opportunity cost. So by definition here, we have our opportunity cost, and an easy way to define this is just that it's the value of our next best option. Or another way, an easy way I like to think about it is it's what we have to give up. In order to achieve something, what do we have to give up? What do we have to give up to get that? And so if we go back to our example with the brownies and cakes here, we have our production possibilities curve, and we said that, hey, at any point, if we wanted to start making one more batch of brownies, what would be our opportunity cost? What would we have to give up in order to do so? And so let's say we started at this point where we were producing 5 cakes and 0 batches of brownies. If we were right here, we wanted to move up to producing 1 batch of brownies. Well, I couldn't just go straight over here because remember, that's outside of our curve. That's impossible. And so in order to stay along that line and use our resources fully efficiently, I would have to give up the production of 1 cake. And so we would say that 1 cake would be our opportunity cost. If we wanted to produce another batch of brownies, what would that cost us? Well, it would cost us the production of 1 cake. So we have a few more examples here. Why don't you guys go ahead and pause the video and take some time to work through these and make sure you understand how to find the opportunity cost. All right, so let's go ahead and work through these problems. If we wanted to start by making 2 more cakes, what is our opportunity cost? So just at any point, if we wanted to produce 2 more cakes, so maybe we wanted to move from the production of 1 cake up to the production of 3 cakes. And so maybe we were here at point E, producing 4 batches of brownies and 1 cake, but we wanted to start making 2 more cakes. Well, again, we wouldn't be able to just go straight up and start making 2 more cakes and be at a point out here because that's impossible for us to achieve with our given resources. So if we slide along our production possibilities curve to producing 2 more cakes, what we would find out is in order to do that, we would have to drop from 4 batches of brownies down to 2. And so our opportunity cost would be 2 batches of brownies. If we wanted to move from point C to point F, so if we were going from C down to F, what would be our opportunity cost? Well, in doing that, we're gaining 3 batches of brownies, but again, it costs us something else. There's a next best option we have to producing those 3 batches of brownies, and what it is would be 3 cakes, because we go from producing 3 cakes at point C to producing 0 cakes at point F. And finally, what's the opportunity cost for our first 4 batches of brownies? Remember, just with the way this is worded, we're going to assume that saying our first 4, it means we haven't started producing any yet. It's our first 4 going from 0 to 4. So that'd be moving from point A to point E. And so if we move from point A to point E, we gain these 4 batches of brownies. But what was our next best option to producing these 4 batches of brownies? Well, it's 4 cakes, because we had to give up the production of 4 cakes. And so you'd see that 4 cakes would be our answer. I do want to work through just a couple more examples to show you some of the variance when it comes to production possibilities curves and opportunity cost. Because just like with brownies and cakes, they use pretty similar resources in order to make one or the other. And so we see the same thing true with the production of other goods. Like here we have the production of cars and trucks. The resources used to produce cars and trucks are fairly similar. And so we're going to go through this example. And so if we were again to plot these points, trucks here along our y-axis, cars along our x, and put on our graph points A, B, C, D, and E, we would get a production possibilities curve that looks something like this. Now what you notice is that we have a straight line here with our production possibilities curve, and because this is something called having a constant opportunity cost, which means that our opportunity cost is remaining the same because our resources are fairly adaptable. In order to produce cars and trucks, you need about the same resources. You need some sort of assembly line for vehicles or whatever it might be. The labor is pretty similar. There might be slight differences, but for the most part, we use pretty much the same resources. And so therefore our opportunity cost is constant. You can see every single time that we go through this and that we add 6 cars, we have to give up the production of 4 trucks. Add 6 cars, drop 4 trucks, add 6 cars, drop 4 trucks. The opportunity cost is remaining constant throughout. But we don't always see that this is the case. The reason this is because the resources, again, are essentially the same to produce those. But that's not always the case within an economy. Sometimes, like we see here, our resources aren't as easily adaptable to go from one to another. And so I'll use that example like we did in class with wheat and cars. The resources to produce each of these are not necessarily very adaptable. We would really have to switch up our production in doing this. And so maybe what we would see is that at point A, we're right here. If we graph out all those points, we would have a production possibilities curve that's actually bowed out. It's not a straight line. It's not constant. What we actually find is that we have an increasing opportunity cost. And what that means is that for every single car that we increase, our opportunity cost is going up in terms of wheat. That car is costing us more and more wheat each time. Our first car only costs us 7 bushels of wheat. Our second car costs us 11 bushels of wheat. Our third car costs us 17. Our fourth costs us 25. You can see that it's costing us more and more each time we go. And now, like I said, the thing that I want you guys to know and be aware of is that this is because our resources are not as adaptable. But in order to understand the why that this is, just to kind of give you some background, whenever we are producing in an economy, let's say we're starting here at point A and we're putting all of our focus on producing wheat. Well, whenever we go to start producing that first car, what we're going to do is we're going to give up our resources that are currently producing wheat. We're going to give up the ones that are the worst at producing wheat. So maybe to build our car factory, we're going to give up that plot of land that's really rocky and not really good for growing wheat. We're going to take our workers that really aren't suited for the fields and instead have them work in the car factory. And so we're not losing out on much wheat and we're gaining a whole car. Now, as you go along, as you gain that next car, you're going to have to give up some better land. You're going to have to give up some better workers, and therefore it's going to cost you the production of more wheat. And each time we go and add another car, it's going to cost you even better workers and even better land and better resources. And so that's why our opportunity cost is increasing as we go. And that increasing opportunity cost here results in a bowed out production possibilities curve.